Hello world viewers, what's up? I hope all you are doing well and your neos and dios are also doing well. First of all, I convey my best regards and heartful thanks to all of you, those who are watching my videos. Good morning to those who are watching me in the morning, good evening to those who are watching me in the evening, and good night to those who are watching me in the night. In the previous video, I told you that I will discuss about the mass, right? And other things also. And at that moment, I also tell that I will discuss about mass. So today we are going to discuss about the relative mass, right? The relative mass we are going to discuss. Before going to discuss about the relative mass, I just want to firstly inform you that you should watch the previous videos by which you can connect it very much good, right? So, and the other things is that there is a WhatsApp channel for all of you, in which you can get all the documents there. If I get some crowd in the WhatsApp channel, then I will provide the notes. Still, I will give that link in the description. You can join on that channel, and by which you can get all the notes regarding our lectures that's happening till now, right? So here today we are going to discuss about the relative mass. So first question is that what is mass? If we are going to our basics learning, that mass is nothing, that is the amount of substance present in a body. Amount of substance present in a body. For example, this is a body and it gains some substance, it gains some space. We know about the mass in our basics physics, right? So today our discussion is about relative mass, and when there is confusion happening at that moment, that is weight and mass. We know about that, that is weight and mass. Weight is a force, weight is a gravitational force, but mass is a amount of substance present in a body. How much substance present inside this body is known as mass, and the SI unit of mass is kg. We all know it. And what is the weight formula? That is equal to m multiplied by g. M multiplied by g. And what is the mass? Mass is mass, and its SI unit is kg, right? So what happens is that we say mass is absolute in every case. In our classical mechanics, when we read about the classical mechanics in our basics physics, that mass is absolute thing. It can't be changed. If we go to the moon, if we go to the planet of Mars, if we go to Jupiter, then mass will be fixed. But the small g, the gravitational the acceleration due to gravity, it will change according to the planets, the other substances. If we go to moon, then g will be changed, right? But mass is absolute at our knowing stage. When we are knowing these kind of things, we know that mass is absolute, right? So this is actually the basics confusion, right? When it comes to and mass and relative mass, when we are going here to mass and relative mass, mass and relative mass, right? So what is mass? Mass is that amount. What is relative mass? Relative mass comes when the speed of that mass is very close to the speed of the light. What is the speed of the light? That is c, small c. And what is value? 3 multiplied by 10 raised to power 8 meter per second. Actually, this is not its fixed value. It is approximately value, but we took it as this, right? So when it comes to the relative mass, when the body is in the very highly speed motion, when it gains about 80 to 85% of c, then relative mass happen. So what is that formula? That formula is equal to m is equal to m naught upon 1 minus b square upon c square root over. This is the basics formula. We'll know the relative mass is equal to the rest mass. It is the rest mass, m naught. It is the rest mass. Means it is when it is not in motion. Okay, it is the rest mass upon 1 minus b square upon c square is known as its relative mass. So today we are going to discuss, we are going to derive this equation in the relativity theory, how it derived here, right? So today we are going to discuss about it. So what we took to discuss about it, we took some consideration. We all know previously consideration. In consideration, we took that me and Einstein are there. Me is the stationary frame and Einstein is the motion frame. Okay, he is in the stash frame and I am in the S frame. Let's draw that. This is X, Y, and Z axis, right? And here there is also another frame. It is in motion. It is X axis. It is. This is the observer. Here I am. Here I am. Okay, here I am. This is the x axis, this is the y axis, and this is the z axis. Like this, This is the O dash. Here observer also there. Here Einstein is sitting. Here Einstein is sitting. Okay. This crazy hair should be there. Okay. So this is the X dash. This is the Y dash, and this is the Z dash. I say this is the S frame. I say this is the S frame, and this is the S dash frame. This is the S dash frame, and it is moving in v velocity along the x-axis. Along the x-axis, it is moving. Okay. What happened here? Here two scenarios will happen. Let's say there is a mass m1 here. There is a mass m1 here, and there is a mass m2 here. This is the m1 mass, and this is the m2 mass. What happened? The m1 mass going towards m2 in something velocity. It is coming towards m1 in something velocity. It is going towards it is u dash velocity. It is coming towards its that same velocity, that is minus u dash. Minus symbolize the direction. It means it is approaching here, right? Plus minus, these are the directions. Not think about a lot of things about the signs, right? So u dash and u dash the same velocity. In the same velocity they are attracting each other. One might say, oh, they are attracting each other. What happens in the next? They will collide each other. They will collide each other. That means the rest, the movement will be stopped here. Here he is in the 5 km per hour. Here it is also 5 km per hour. When it mix up, it will 5 km per hour. So after some time, it will collide. It will collide. So this will be m1 and this will be m2. So both will be stopped. Both will be stopped. Both m1 and m2 will be stopped. According to whom? According to Albert Einstein. Because he is in the S dash frame and he is moving with the velocity v velocity, right? So it will collide after some times. After some times it will collide and it will be m1 and m2, and both will go in the v velocity. According to whom? According to me. Here Sudipta is sitting, right? So for him, these two scenarios are looking different. These two scenarios are looking different to him. It looks like the same velocity. It will look not the same. It will look like it is going on u1 velocity and it will go going on u2 velocity. I am saying that, oh, it is going on different velocity. It is going on different velocity. Why? Because v is happening there and I am here in the rest frame. I am in the stationary frame. Okay. So here m1 and m2 will be collide each other. It is rest according to Albert Einstein. For according to me, it is going in the v velocity. It is going in the v velocity. So I am observing here what happens in the S dash frame. What happens in the Einstein frame, right? So we will discuss about that. So to discuss about that, to derive about that, I say that I use something different, and I use something different, that is the velocity addition theorem. I just use that velocity addition theorem, and the velocity addition theorem will be discussed in the next videos, because we are going from crown to down. We are going from E is equal to mc square, then we are going Doppler effect, then we are going what is time dilation, then we are going what is Lorentz transformation, what is Galilean transformation. Now we are going to relative mass. For relative mass, we use velocity addition theorem. What is velocity addition theorem? We are not going to discuss here. We discuss that in the next video. I just use that formula in this video. What is that? That is u is equal to, u means that's u. This u is equal to u dash plus b upon 1 plus u dash b upon c square. So this is the velocity addition theorem. What I use? This is the velocity addition theorem. Okay, this is the velocity addition theorem. For u1, what will happen? For u1, its velocity is u dash. For u2, its velocity is minus u dash. So for u1, we can simply write it u1 is equal to plus sign. It will be plus sign u dash plus b upon 1 plus u dash b upon c square. The same will be happen when it comes to the u2. When it comes to the u2, for u2 it is minus u dash because it is coming towards the u1, right? According to this frame. Okay, so it is just like it will minus u dash plus b upon 1 minus u dash b upon c square. So we know these two scenarios. We got what is u1, we got what is u2. Okay, after knowing it, we are remembering something that happenings in our classical mechanics also. We know there is conservation of momentum. Have you forget it? Conservation of momentum. Before collision and after collision, the momentum is same. The total momentum is same. What is momentum? The amount of motion present in a body. We know it is the momentum, right? So what is the momentum before collision? Before collision, it is okay. It is m1 u1. What is it? It is m1 according to me. I am seeing those kind of things. According to me, who is the observer here? Here I am seeing what is happening in the stress frame. So according to the conservation of momentum, according to the conservation of momentum. Okay, what is that? m1 u1 plus m2 u2 is equal to m1b plus m2b. Why use it? Because they are rest according to Albert Einstein. For me, these are also moving in which velocity? In the velocity v. Both are moving in the velocity v. That's why I use it, m1b plus m2b. Let's assimilate m1 and m1 together and m2 and m2 together. Okay, what will happen? That m1 u1 minus m1b is equal to m2b minus m2 u2. Okay, let's take common as m1. It will be u1 minus b is equal to, let's take common m2. It will be b minus u2. We do it from this point. Okay, we do it from this point. The next step will be happen here. Let's say then what will happen in the next step? In the next step, it is going to happen that m1. What is the u1? u1 is u dash plus b. Upon 1 plus u dash b upon c square minus b. Okay, is equal to m2, that is b minus u2. What is u2? That is minus u dash plus b upon 1 minus u dash b upon c square. So we got this kind of points. We have to derive. What is we have to derive? M is equal to m naught upon 1 minus b square upon c square. This thing we have to derive. So for this, we have to take the scenarios of m1 and m2 ratio, right? So let's calculate. Let's prove the LCM. The simple fraction addition theorem. It's not theorem. The fraction addition, you don't know it. You know it. Just remember. m1, what will be the LCM? Your LCM will be 1 plus u dash b upon c square. U dash plus b. It will be minus b and minus u dash b square upon c square, right? So this is the left hand side. Like this, it will be m2. What will be the right hand side? Do the calculation. What will be the calculation? That is b minus u dash b square upon c square, and minus will be plus. That will be plus u dash minus b upon 1 minus u dash b upon c square. If you can't see, I just say in the mouth. What I write here, that it is b multiplied by 1 is b minus u dash b square upon c square, and minus will be plus u dash minus b. So I just write these kind of things, nothing I write. Okay, look at the numerator of both sides. It is plus b minus b u dash b square upon c square. It is also the minus is here. If you see, the denominator of both sides are equal. The numerator of both sides are equal. It means we can cancel out both side numerator. The numerator will be cancelled out. Okay. So in the next step, I am going to do that. I just took m1 upon m2. m1 upon m2 is equal to, what will happen? m2 is coming here. That means it will go there. 1 plus u dash b upon c square upon 1 minus u dash b upon c square. So we got this kind of equation from here. Let's say this is the equation 1. So we are going on that stage, that is m1 upon m2. We got this point still now. This is m1 upon m2. It is 1 plus u dash b upon c square divided by 1 minus u dash b upon c square. So this is the scenario we do it, right? So what we have to derive in the next step. We have to just derive in the next step that what is 1 plus, what is the numerator and what is the denominator. For this, the derivation will be completed. It is very simple. So to find this, we use something like a very big special instrument here. We just use a very special instrument. What is that instrument? I'll discuss here. Let's erase this. I will discuss here. I will provide you the notes in the WhatsApp channel. I tell you, I will give that description in the link. And if you join more and more people, after that I will provide the notes. Notes are ready with me. Why I don't share? Because there is no crowd in the WhatsApp channel. I urge everyone to join that channel. Then I will provide all the PDF forms, the notes that are made by me. I will share those kind of things, right? So join that WhatsApp channel as quick as possible. Okay. So to have the value of 1 plus, to get the value of 1 plus u dash b upon c square, we have to solve 1 minus u1 square upon c square. We have to solve 1 minus u1 square upon c square. 1 minus u1 square upon c square. It's very simple. We just use that instrument. I say it is like instrument. It is the Cambrian marker, and the darker theme is this much, and this is the non-branded marker, and this much. It's not about the branding. Okay. Anyhow, 1 minus u1 square upon c square. So it will be 1 minus, what is the u1? U dash plus b. What is the u1? u1 is equal to u dash plus b upon 1 plus u dash b upon c square. You know it. So 1 upon c square is there, and what is the u1? U dash plus b upon 1 plus u dash b upon c square whole square. Okay. So what will after that? We have to get this point. We have to get this point. Why? The ratio is to find this and this. Then our job will be done one time. Okay. So it will be 1 minus 1 upon c square multiplied by u dash plus b whole square upon 1 plus u dash b upon c square. Okay. It will be also square. P upon q square, that's equal to p square upon q square. Okay. Then the LCM will be this much. That means 1 plus u dash b upon c square whole square minus 1 upon c square u dash plus b whole square upon 1 plus u dash b upon c square whole square. So this will be the point, and we just have to simplify all these kind of things. So where we simplified? I think I have to erase. I'll just write it down here. I just write it here. m1 upon m2 is equal to 1 plus u dash b upon c square upon 1 minus u dash b upon c square. This we have to derive this much and this much. I just erase it. Okay, I just erase it. Okay, I just erase it. So what is that? Here you can see here. So it is a plus b whole square, that's equal to 1 plus 2 u dash b upon c square. Okay, plus u dash b upon c square whole square, right? Minus 1 upon c square, that is u dash square plus 2 u dash b plus b square. Okay, upon 1 plus u dash b upon c square whole square. So let's open that bracket. 1 plus 2 u dash b upon c square plus u dash b upon c square whole square minus, it will be minus u dash square upon c square plus, sorry, it will be minus 2 u dash b upon c square minus b square upon c square upon this much. What is that? 1 plus 1 plus u dash v upon c square whole square. So this is the thing we got here. What cancel out here? Plus 2 u dash v, 2 u dash v upon c square minus 2 u dash v upon c square will be cancel out. So this much and this much will be cancel out. What will the remain here? The remains are, what are the remains here? If you took it 1 minus, it will be 1 minus v square upon c square. I took it here, 1, that is minus v square upon c square, and I just took the common. These twos are cancel out. I took the common, that is minus u dash square upon c square is common. So what will here remain? That is 1, and if you took it 1 minus, it will be v square upon c square will be the remain. It's c to the power 4. It takes c square, c to the power 4, right? Upon 1 plus u dash v upon c square whole square. Okay. So what is our required point? Our required point is to find this, and in the left hand side, this is this much, right? This much is there. Okay. I just erase it. Okay. So look at the relation between this and this. Okay. So what we have to do here is I just use 1 plus u dash v upon c square whole square is equal to, it is going to this side, that means it will come to this side. It's lower to higher, higher to lower. Okay. So what is the remain? We can say it will be common. It will be common here, right? 1 minus v square upon c square is 1 minus u dash square upon c square upon, who is here? Here this much is coming here, that means 1 minus u1 square upon c square. Look at u1 and u dash, not to be confused. When I took u1, I just bold this letter. Okay, c square. So we don't need square. We need only that much. That means when we remove the square, it will be the root over. When we remove the square, it will be the root over. That means we got this point. That is 1 plus u dash v upon c square is this much. Like the same way, I solve to get this much. At the same time, if I get to get this much value, so I have to solve what? I have to solve u2 square, 1 minus u2 square c square. So to have 1 minus u1 v upon c square, minus sign when it will come, I have to solve what is 1 minus u2 square upon c square. So what we have in the next set, in the next stage, we have 1 minus u dash v upon c square will be, what is that? Just nothing. It will be u1 will be u2. The same way. If we solve that the same thing, then the same way. You can use this in the similar method. Similarly, we can write. Similarly, what we can say? 1 minus v square upon c square multiplied by 1 minus u dash square, here it is u dash square upon c square, right, upon 1 minus u2 square upon c square, total root over. So we got this point and this point. So we have just to ratio. We have just to, just divide both these two. Okay. We have to just divide. In the conclusion stage, we point out in the conclusion stage, right? So here we come here. What is that? So it is in equation 1, it is m1 upon m2. So m1 upon m2 will be, what is that? This much and this much. This much value is this. What is this? 1 minus v square upon c square multiplied by 1 minus y dash square upon c square upon 1 minus e1 square upon c square, the total root over. Okay, the equal sign should be in the middle of the fraction, so that's why I write it again upon, what is that here? 1 minus v square upon c square. Okay, 1 minus u dash square upon c square. What is the 1 minus u2 square upon c square, root over, the whole root over. Okay, if you see the numerator of both the fraction, the numerator of this much and the numerator of this much, both are equal. That means it is same. So what will happen in the m1 upon m2? M1 upon m2, it will just inverse. Okay, what is that? 1 minus u2 square upon c square upon 1 minus u1 square upon c square, because both numerator and numerator will be cancelled out. Total root over. That's total root over. Okay. Okay, so here we got this point. Here we got this point, and this is the value we are going to calculate. Okay, so m1 upon m2 is this much. So what happens here? I say the u2, I mean the, what is u2? The velocity of m2. What is u1? The velocity of m1. Okay, if we took what, how can we get this simple notation? We just have to say the conditions, right? We have just to say the conditions. What will have to happen here? So what happened here? Here nothing happened. That if m2 is in rest, that means u2 is equal to 0. That means u2 is equal to 0. If m2 is in the rest, then u2 will be 0. That means 1 0 upon something that is equal to 0. That 1 minus that will be, and let's say the m2 is moving, the m1 is moving in a velocity v. The m1 is moving in a velocity v. That means the e1 will be v. The e1 will be v, right? So what will happen? That is m1, for m1 I can say here, for m1 I can say m, for m1 I say that's it m, for m2 I say let it m naught, because it is in rest. For that simple notation, everything is done already. I just want to see you the scenario. Okay, so it will be m1 equal to, or we can say m is equal to 1 minus 0, that is equal to 0, 1 root over, that is 1 upon 1 minus u1 is b square upon c square root over. This is the m is equal to 1 upon, m upon m naught is equal to 1 minus p square upon c square root over. If you say that, I just use that m1 upon m2 is equal to 1 minus, if you say this is u1 square, this is u1 square upon c square root over. So what I take the consideration, that m2 is in the rest and m1 is moving in the velocity b. Okay, so this condition we got after that. Okay, so it will be what happened. So this will be m is equal to m naught 1 minus v square upon c square root over. Okay, so this point we have got. What does it mean? It means if a mass is moving in a velocity to close to the speed of the light, then the mass also increase its number. That means we can't say mass is absolute. Mass is also a relative term. It is a subjective term. The speed of that frame is very much. If it is very close to the speed of the light. So here all the scenarios are down here. I think it is very simple, and I think you realize all these kind of things about mass conception. If someone is telling about mass in the classical mechanics, okay, we can agree that it is the absolute thing. But I say always, there is nothing constant in the universe. Everything is subjective. Everything. For exception, we may take those kind of exception. But when we go to the rocket science, when we go to any kind of space program, then there is no any kind of exception are working. Still Newtonian physics happening. But when we go to the quantum mechanics, when we go to the quantum palace, then these scenarios will be changed. And that the theory in which Einstein penetrated a lot. He gave a extra boost on this kind of thing. There is a special theory of relativity, and he also gives certain kind of theories, and many scientists also agrees those kind of scenarios, right? Don't look that scenario, that modernization not in the sense of looking. It is about your mentality. In the 1905 someone is thinking about 100 years after. That is the modernity. That's the mentality. That's having the old wise look like crazy hair. Still he has the mentality after 100 years. That's theories are also in a very mystical things also till now. Okay, so here I conclude my video. Before concluding, I just say you that subscribe this channel to grow this channel to having this kind of content, to grow the scientific mentality inside of people all over the world. So this channel should be grow, right? So for the notes, I tell that WhatsApp channel link is in the description. And still, if you have any kind of doubt, any kind of questions, just ask me in the comment section that is near the video. Okay, and hit that subscribe button, turn on that notification button also. You can get the notifications when I upload any kind of videos. Write the questions. I actually wait for your questions in the comment section, but you are not asking. Still, I have that positive sense one day this channel will grow. So here I conclude my video by saying thanks you for watching this video.